Okay, hello everyone, and welcome to the Code booth and to our session this afternoon, where together we will be building a private DevOps environment on VCF using Tanzu and VKS. As a means of introduction, my name's Adam Trubridge. I am a core solution engineer at VMware by Broadcom, and I'm being joined by...
Yeah, hello, my name is Viktor van der Berg. I'm working for the Tanzu business unit within Broadcom. Joining Adam today. My part of the presentation will be at the end, after Adam introduced all the the VKS stuff on top of VCF. I will be talking a little bit about Tanzu. So, giving it back to Adam.
Perfect.
And you will see me later.
Thank you. So the focus today is on VCF and primarily a demo only, but I will be starting off with a couple of slides to begin with. We will be starting off with a sort of fairly vanilla VCF environment from scratch, and we'll be going through that, enabling the supervisor, the IaaS control plane, and then at the end we will be deploying an example application onto a cluster. So we're talking about building a DevOps environment, specifically in VCF. There are two personas that we talk through in this story. On the left-hand side, we've got the developers, the consumers of the platform, and on the right-hand side, the sort of VI administrators of our platform. And both of these personas have differing interests and demands of the platform. The developers want to have consistent, familiar tooling available to them, so your typical kubectl, CLI, and the infrastructure as code tools that they are used to using. Primarily, they also want this to be self-service, so they want to be able to log into the platform and consume resources how they want to, without too many blockers being in the way for them to reach their goals. Administrators, on the other hand, will primarily be interested in the governance and compliance of the framework, so making sure that they can control the resources that their developers are consuming. So how are we going to build out this DevOps platform? Well, we look at this as a stack of components, starting at the bottom with the virtual infrastructure layer, which, as we know, is provided by VCF. So you've got the compute, the networking, and the storage already integrated into the stack. On top of that, we can enable the vSphere supervisor, which provides a set of key services for our DevOps platform. The ability to create virtual machines in a declarative manner, and the VKS service, which is what we'll use to create a Kubernetes cluster. Our admin will be responsible for the provisioning and the deployment of this infrastructure, and of course the consumer to consume that and run the applications that they want to. We provide a selection of sort of additional services on top of the supervisor. So, for example, around ingress control and an image registry that the developers can use to consume their applications from. And of course, a selection of guardrail options for our administrator to manage the governance of our environment. What we've got here is a bit of a graphical example of what all of this will look like when we bring it together. So you've got the VCF virtual infrastructure underneath, providing that compute, storage, and networking. We'll wrap a supervisor around this to provide that API access, and then on top of that, we can create our developer services. These are all grouped up into what's called vSphere namespaces, which are sort of resource envelopes that we can then deploy Kubernetes clusters and Kubernetes pods directly to. And what we're doing when we enable this supervisor really is we're turning our vSphere cluster into a Kubernetes cluster. And what are the two sort of key ingredients of a Kubernetes cluster? Well, you've got the control plane and the worker nodes in a cluster. Our supervisor will be providing those control plane resources. So that will be providing a kubectl API into our VCF environment, and our ESXi hosts will be sort of converted into worker nodes that we can that the supervisor can deploy Kubernetes resources directly to. And the final slide. A key sort of differentiation to call out is when we refer to namespaces in vSphere, that's a little bit different to namespaces in Kubernetes. What we're doing at the vSphere level is carving up that cluster into those resource pools that our developers can then consume resources out of. This tends to be on the administrator to provision those namespaces and provide those guardrails around them, and then our developer can manage their own namespaces, their own Kubernetes namespaces and clusters within these constructs. So what I'll do is dive into a demo environment, and we'll go through that process of showing you what the supervisor has created on VCF. We will build a VKS cluster and deploy an example application to it. So what we have available to us here is a fairly typical bare bones VCF environment. You'll all recognize this as we've got four physical nodes running vSphere, vSAN, and NSX, the core VCF components. What I've done before this session is enabled the supervisor service within vSphere. I won't go through the full process of that in this session because it takes a couple of hours, but if anybody wants to talk about it after the session, then I'd be happy to walk you through that. What it's done is it's deployed those 3 supervisor control plane virtual machines that I referred to. So these are our Kubernetes control planes that are providing that kubectl API environment for us to connect into VCF with. And then each of our namespaces that we create has a resource pool within vSphere. So our infrastructure administrators can manage those in a way that they're familiar with, and we as developers can consume resources out of those. We manage this using the workload management tab in vSphere, and as you can see here is a list of the namespaces that I've already provisioned. If you were in our session this morning, you might recognize a couple of these names from the demo that Viktor showed. But we're going to be creating a new namespace so that you can see some of the requirements in order to create that and how we would push an application to it. So if I go and create a new namespace, I'll select the supervisor that I've already deployed, called Demo Supervisor. We'll give it a name, so I'll call this something that I haven't already used. Namespace 09 Explore. Behind the scenes, that will be creating a Kubernetes namespace within our supervisor for us to access into using the API. But what we've got here is a graphical interface for our administrators to control this namespace and provide some resource guardrails around it. I'll set some permissions, so I'll give my group of developers edit access to this namespace so that they can utilize it. I need to provide them storage, so where our developers are creating persistent volume claims and clusters within our namespace, they need storage to be able to consume to create those resources. And that is done through storage policies in the same way that a virtual machine would have a storage policy. So I've created that example policy called TKG, which is a vSAN storage policy, and that's what I'll be using for my persistent volume claims. Then finally, I need to provide my developers with some virtual machine classes, and these are the classes that they'll be able to use to define the virtual machines that they're deploying. In our case, those virtual machines will be forming a Kubernetes cluster, and these can sort of be seen as t-shirt sizes, I guess, for virtual machines that you're providing to your developers. So we can change things like resource reservations and pass PCI devices into these templates that our developers can use. I will make the large, medium, and small sizes accessible within this namespace, and you'll be able to see what this looks like in the Kubernetes API as well. So we now have that namespace configured within the UI. As an administrator for this session, my role is done. I'm passing over to my other hat as a developer to go in and consume this namespace and deploy an application to it. Now, as a developer, my sort of interface of choice would be the CLI. Maybe I've worked with other Kubernetes flavors in the past, and I'm used to using the kubectl API, which is of course available to us now in vSphere. I will connect into that environment using the kubectl vSphere plugin. So I'm logging into this IP address, which is my supervisor control plane, using my vSphere credentials. And here you can see the list of contexts that I have available to me. The top context here is the supervisor control plane itself, and we have a list of namespaces underneath that. So the namespace that I just created in the vSphere UI is available here as NS09 Explore. We can have a quick look at what that has made available to us. So if we config, if we just switch into that namespace to make it a bit easier. If we have a look at what nodes are available to us, you can see what I meant when I showed that diagram of the Kubernetes cluster, where we've got those 3 supervisor control plane virtual machines have been configured as our Kubernetes control plane, and each of our ESXi hosts themselves are configured here as worker nodes for deploying resources to. Now, we can deploy pods directly to those ESXi hosts as worker nodes. This is called vSphere pods. However, in the example today, we want to go a step further than that and deploy an entire cluster within that namespace that we will use to create our application. So clusters on vSphere are defined and created using what's called the Cluster API, and this allows us to manage a Kubernetes cluster as a Kubernetes resource itself. So as you can see here, we've got a sort of a familiar looking YAML Kubernetes manifest, but in this case we're defining a cluster. So what I've done is created this example manifest for a fairly small Kubernetes cluster. I've given it a name, specified the namespace for it to deploy to, the networking stack for that Kubernetes cluster, and the topology of it, which is key here. I've specified 1 replica for the control plane, 1 replica for the worker nodes. And here you can see those storage policies that I introduced in the user interface. So as a developer, I'm consuming that vSAN storage policy that my admin gave me access to by referencing it in the manifest for our cluster. And additionally, you can see here the virtual machine class that my admin gave me access to. Best effort large in this case, that is what I will be using as the template for the virtual machines that build out my cluster. So deploying this to my vSphere namespace is as simple as deploying any other Kubernetes resource by applying the cluster YAML manifest, and hopefully, there you go. It's configured as a Kubernetes resource, and now in the background, the supervisor is going away and deploying that cluster. If we hop back into vSphere, you'll be able to see within the logs in a couple of seconds. There you go. It's going through. It's created a resource pool for our cluster. It's going through requesting the OVF files required to build out that cluster, and it's deploying that to our VCF environment. That cluster will take approximately half an hour to deploy, which we don't have time for in this session today. So I've created another one as an example that we will deploy an application to. And I'll show you what that looks like in the vSphere client. As you can see, our namespaces are available here on the infrastructure tab in vSphere. You can see the namespace that I deployed earlier, NSO9 Explore, where our cluster is currently being deployed. But in my pre-deployment example, which I'll be using to demonstrate today, you can see that a cluster has been given a resource pool, and those worker nodes are being deployed as virtual machines within vSphere. They are tagged as developer managed, so those are being automatically deployed and lifecycle managed by our supervisor. So what I should be able to do now is log directly into that cluster and deploy an application. So I will log out of the supervisor that I'm currently logged into and run the same command, but this time I will specify a Kubernetes namespace and a cluster that I want to connect into. So you can see that cluster name there matches the cluster that I showed you in the vSphere UI. So we'll log into that and hopefully be able to deploy our application. Perfect. So just to show you the difference, if we run a get namespace, we are now in a fresh cluster. So this is a default VKS cluster. The namespaces that are created alongside that, we can go in and create namespaces and applications in the way that as developers we would be used to. So what I'll do is I'll create a new namespace for my application. I'm using Yelp as the example in this session. So I'll create a namespace for it. I will label that namespace so that I've got the privileges to deploy pods to it, and then I'll be able to apply my application manifest. Ooh, that's not good. That's better. So there we go. We've been able to deploy our example application here, Yelp, to that cluster. So hopefully, if we have a look at what that's deployed within our cluster, we've got some deployments being created and some services which, over time, after Kubernetes has done its magic, we will be able to view the interface for this application, which will hopefully take a couple of seconds. There you go. We're starting to see some pods up and running. Being slow this afternoon, but when it's finished, we will have a working application within that cluster. Okay. This might be my internet connection. Let's have a look what's going on. Okay, we'll have to skip over that. What I have just realised, and I apologise for this, rather than deploying that cluster to a new namespace, I've just overwritten the cluster that I had already set up as a demo. So I believe in the background what it's done is just deleted what I have just created, and I can now no longer access it. But we've got a brief glimpse of those pods being deployed and those services being created within our cluster. And if it had gone to plan, we would have been able to log into that service IP and had a look at the example application that I was hoping to show. But the key thing that I wanted to call out was how easy it was to go through and define that cluster using the cluster API, and to deploy it to a namespace that we created in vSphere in a declarative and a self-service way, with that cluster being available in vSphere as a resource that our infrastructure admins can also manage. What I will do instead now is pass over to Viktor, who's going to have a quick chat about what you can then further add on to this with Tanzu Platform.
Yes, thank you, Adam. So what we've seen so far is building a Kubernetes layer on vSphere, on VCF, right? The question is done, and what is then next? So let's say if we don't want to apply a YAML file to the cluster, but we want to build an actual application. We have a source code, we have an app. How do we bring that to production? How do we manage an environment not with just one Kubernetes cluster, but if we have multiple Kubernetes clusters? How do we manage a maybe multi-cluster, multi-zone Kubernetes environment? So this is where Tanzu Platform comes around the corner. So Tanzu Platform is something you can deploy on top of VMware Cloud Foundation, or let's say that differently. You can manage your Kubernetes runtime that is running on VMware Cloud Foundation with Tanzu Platform. Tanzu Platform will bring you things like an application framework, services, a runtime, databases. We can deploy those as well. Tanzu Platform provides you with a full stack of different capabilities that are valuable for your developers. It starts with the layer that can do the Kubernetes management for you, or Cloud Foundry management. We provide support for Spring-based applications. Spring is a framework on top of Java, and the Tanzu business unit within Broadcom is the custodian of the Spring framework. We also provide a catalog of curated open source images. If you are working in this cloud-native world, you will be working with open source software. And the question is then, where's this software coming from? How do I know that I can trust this open source software? What libraries are being used? Is it tested? Are there any maybe CVEs? Is there a virus scan done on my open source software? This is also part of the Tanzu Platform, and we use something called Tanzu Application Catalog for that. We also provide support for open source technologies as part of the platform. For example, PostgreSQL, MySQL, RabbitMQ, very technologies that are used very often in these kind of scenarios. The last important thing to tell you is that if you are thinking about deploying apps to Kubernetes and you want to bring your app for what is called from source to production, then you have to go through a couple of steps. What we are doing with Tanzu Platform is we are abstracting Kubernetes away for you. We bring you 4 simple commands called the golden commands, and with these commands you can easily build an application from source. So you have the source code. The Tanzu build command will build a container for you, push it to a registry. You will also create it will also create the YAML artifact that you need to deploy to Kubernetes. The next step is to deploy the app to Kubernetes. So that means push the YAML file, pull the container, deploy the app. Then the app is running on Kubernetes. Then you maybe want to bind to a database, for example PostgreSQL, MySQL, or any of the other choices that are available. We can manage that for you with Tanzu platform on the Kubernetes layer as well. So that means that we get the actual connection out of the application and bring it to the Kubernetes layer. And the last option we offer with this is that we can do a scaling of your application, either within the namespace where the app is running, but we can also scale across multiple Kubernetes clusters and manage the global site load balancing, for example. So this is a bit where, let's say, VCF, VKS ends, and this is the next step if you're into application development, bringing your apps to Kubernetes. Tanzu platform is for sure worth a look. So I would like to all invite you to our booth over there. We have a live demo of this platform available to show you a bit more of how this works. So feel free to come by and have a chat about this, and we can show you what we can do with this.
Thank you, Viktor.
We're running out of time, so...
Yeah. All right, well that's our 25 minutes over. And if there's any further questions, then come and see Viktor and I. I'm happy to help on the VCF side, and Viktor can walk you through Tanzu platform. Other than that, I hope this was useful, and we'd appreciate if you could take the survey. And thank you for attending.